Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. The human brain is the most complex structure in the known universe, containing nearly 86 billion neurons and trillions of connections. But what if we've been looking at its wiring all wrong? For decades, we've treated the brain like a biological computer, a series of chemical signals and electrical pulses traveling across neurons via saltatory conduction. But a radical new hypothesis in the field of quantum biology suggests that your brain might actually be utilizing the same physics found in the most advanced particle accelerators and experimental quantum computers: superconductivity. In the realm of physics, superconductivity is the holy grail. It is the ability of certain materials to conduct electricity with exactly zero resistance. To achieve this, scientists usually have to cool materials down to near absolute zero, minus 459 degrees Fahrenheit, the temperature where almost all atomic motion ceases. At these extreme temperatures, electrons pair up into what are called Cooper pairs. These pairs act as a single unit, gliding through a molecular lattice without colliding with atoms or losing a single joule of energy to heat. The brain, however, is a warm, wet environment, averaging about 98.6 degrees Fahrenheit. According to the laws of classical physics, this biological heat should cause enough atomic noise to instantly destroy any fragile quantum states. This is known as the thermal decoherence problem, and for years, it made the idea of a quantum brain seem impossible. Yet, when we look closer at the synapse, the microscopic gap where two neurons communicate, the speed, precision, and efficiency of signal transmission seem to defy classical expectations. Some researchers are now proposing that the proteins and fatty acids within our synapses might be engineered by billions of years of evolution to shield quantum coherence. Specifically, look at the geometry of the synaptic cleft. It is a confined space where electric fields are incredibly intense and highly organized. Within this architecture, something strange happens. Could the human brain be a high-temperature superconductor? While we traditionally think of superconductivity as something requiring liquid nitrogen or specialized pressurized chambers, some biological structures might mimic these effects through a process called Fröhlich condensation. This theory, first proposed by physicist Herbert Fröhlich, suggests that biological membranes can vibrate in a synchronized, coherent way when they are supplied with metabolic energy. This vibration creates a state that behaves mathematically and physically exactly like a superconductor, even at room temperature. In essence, your neurons might be creating virtual, absolute zero pockets where information can flow without the friction of heat. We can't explore the concept of the quantum brain without mentioning microtubules. These are the tiny, tube-like structural skeletons found inside every cell, including neurons. Renowned physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff have long argued that these microtubules act as quantum waveguides. If the brain functions via these superconducting pathways, it would explain how we can process massive amounts of sensory information in real time while consuming less power than a standard 20-watt light bulb. Our current digital computers would require a small power plant to perform the same level of associative pattern recognition. Evidence for this biological hacking of physics is growing. Recent studies in the field of photosynthesis have shown that plants use quantum coherence to find the most efficient path for a photon to reach a reaction center. They essentially test all possible paths simultaneously. If a simple leaf can utilize quantum mechanics to maximize efficiency, why wouldn't the most advanced organ in biological history do the same? In the human brain, we observe long-range phase transitions, sudden, massive shifts in brain activity that look remarkably like the phase transitions seen when a metal becomes a superconductor. When we say the brain functions at absolute zero, we don't mean your head is physically freezing. Instead, we are talking about a state of functional cold. This means the information transfer inside your synapses is so perfectly organized that it acts as if there is no thermal interference at all. It is a state of ordered silence. Imagine a crowded stadium where everyone is shouting randomly. That is thermal noise. Now imagine if everyone suddenly stops and begins to sing the exact same note in perfect harmony. That collective resonance allows a single whisper to be heard across the entire field without being distorted. This is how your brain might be cheating the laws of thermodynamics, creating a quiet channel for consciousness to emerge. If the superconducting synapse theory is eventually proven, it changes our fundamental understanding of who we are. It would suggest that consciousness isn't just a byproduct of basic chemical reactions, but a fundamental quantum state of the universe. It would explain why artificial intelligence, despite having millions of times more raw data, still struggles to match the creative intuition and gut feelings of a human. Our brains aren't just calculating numbers, they are resonating with the fabric of reality. We are not just biological machines, we are quantum resonators. For more incredible facts like this, don't forget to subscribe and turn on notifications.